Module 2, Lesson 7, the relationship between visual fraction models and equations. Looking at the I can statements, I can show and explain the connection between models of fraction division to multiplication. So today we're going to look very specifically at the connection that we have found between multiplication and division and try and understand exactly what's going on here. We will then extend that understanding to what is called the invert and multiply rule. So we're going to make very clear the connection between multiplication of fractions and division. All right, so we have a vocab word that we'll need to pay attention to today. It's called multiplicative inverse. So obviously it's got something to do with multiplication, and we need to know what an inverse is. A multiplicative inverse is two numbers whose product is 1. So product means we're doing some multiplication, and when we multiply, we will get 1. So for example, we have 3/4 and we have 4/3, and when we multiply them, we get 12/12, which is 1. So 3/4 is the multiplicative inverse of 4/3, and 4/3 is the multiplicative inverse of 3/4. Multiplicative inverse is also referred to as a reciprocal. So when they say find the reciprocal, it's what you're going to multiply by to get 1. And of course, here is the example that I just did. And then we can express this in a general form. In a general form, we replace these numbers with variables. So we have a fraction, a to b, and here's the reciprocal b to a, and b and a and a and b, and they all, when we use these reciprocals, are equal to 1. So in this one, in this particular example, I've got a times b over b times a, and that will be equal to 1. And in this one, I've got b times a over a times b, and that is equal to 1. They are all equal to each other. And importantly, we are observing the reciprocals. So this was a over b, and this one is b over a. Reciprocal. Multiplicative inverse. All right, so we're going to take a look at a partitive interpretation to see how the multiplication connects directly to the multiplicative inverse and using multiplication. So we've got our 3/4 divided by 2/5, and as a partitive, we are answering the question 2/5 is 3/4 of some number, or we could also say 3/4 is 2/5. Of a number. And so what we would do, kind of stepping through this here, we're going to create our 2/5. 1, 2, 3, 4. So here is my 2/5, and we know that 3/4 is the 2/5. Three-fourths is 2/5 of what number, or 2/5 is, 3/4 is 2/5 of some number. Now, we have to do a little bit of thinking our way through this. If we look very carefully, we can see that 3/4 has been split into two pieces. Here's a piece of it, and here's a piece of it. So I'm going to have to do a little bit of work here because this isn't going to cut apart very nicely for me. So I need some perhaps common denominators, or I need to do a little bit of work here. What I'm going to do is go back to something we're very comfortable with. I'm going to take 3/4 and I'm going to divide it by 2. And I can use a quick model to do this. So here's my 3/4. And I will divide it by 2. And I can see in my 3/4 I have 6 pieces. And there are eighths. 1, 2, 3, 4, 5, 6, 7, 8. 6 eighths. And if I want half then, 3/4 divided by 2, if I want to take this 3/4 and divide it by 2, I've got 3/8. So here I have 3/8, 3/8, 3/8, 3/8, and 3/8. And I can add all this up. So 3/4 is 2/5 of 3, 6, 9, 12, 15, which will give me 1 and 7/8. But let's step back here for a second and look at what I actually did at the beginning of this process. What I did is I took 3/4 and I divided it by 2. And once I had divided it by 2, I multiplied it times 5. Now another way of thinking of this is I found half of 3/4 and I multiplied times 5. This right here can also be written as 3/4 times half times 5. Now I'm going to put some parentheses around this half times 5. And if I take half and I multiply it times 5, I'm going to get 5 halves. So I've got 3/4 times 5 halves. And all of this is, of course, equal to our division problem, 3/4 divided by 2/5. So if we look right down here at the end, and I think I might even come up and write this up here, 3/4 divided by 2/5 is equal to 3/4 times 5 halves. Here we have reciprocals of each other, the 2/5 and the 5 halves. This was a division problem, 3/4 divided by 2/5, and I multiplied by the multiplicative inverse. Now, if we think back through several other lessons that we have worked on, we have worked very hard to establish that dividing by 2 is the same as multiplying by 1/2. These are multiplicative inverses of each other. 2 is 2 over 1, and put a multiply by half. And here we have half, so we divide by 2, and that is the same as multiplying by the multiplicative inverse. This multiplicative inverse is called the invert and multiply. So for example, 3/4 times 5 halves. 15/8 equals 1 and 7/8. But it's really important to me that you understand how this happened. How did we get to this invert and multiply? And so it's very important to me that you can look and say, okay, when I drew the model, I had 3/4, and I found half of it, and that got me 3/8. And then I had 5 of them, and that got me to 15/8. So this 3/4 divided by 2/5, we take the 3/4 and we find the value of 1/5. So there's our divide by 2. And then we scale it up because we need 5/5. All right, let's look at another example. And here we have a measurement interpretation. And we've got 3/5 divided by 1/4. And the question is, how many fourths are in 3/5? So 3/5 divided by 1/4. 3/5 is how many fourths? And if we model this out, first thing I'm going to do is get me in unit form here and get some common denominators. So I'll scale up to 20th, multiply this times 4, and I've got 12 20ths, and multiply this times 5, and I've got 5 20ths. So I need some 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There, I've got some 20ths. And it says here that I will have 3/5, which is 12 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, here is my 12 20ths. And I am trying to answer the question of how many 5 20ths there are. 1, 2, 3, 4, 5. So there's 1. 1, 2, 3, 4, 5. 5 20ths. And then I've got a partial group. 1, 2, 3, 4, 5. I've got another 2 pieces out of 5 that I need. So I made 2 whole groups. And I was making groups of 5, and I had 2 left. So I find that the quotient is 2 and 2/5. But let's take a look and see what this looks like with the invert and multiply. 3/5 times 4 over 1. And I get 12/5, which when I divide will give me 2 and 2/5. Great. But let's think through this a little bit more carefully and figure out exactly why does this work out for us. So I have 3/5 divided by 1/4, and I turn this into 12 20ths divided by 5 20ths, and I found out that that was equal to 12 20ths. 12 20ths, no. 12 20ths divided by 5 20ths. So I hope you can see I'm connecting this through all of the different things that we have done. And that will give me 12 divided by 5, which gives me 2 and 2/5. So we've thought through all of the unit form that we've done, all of the finding the common denominators, and all of this stuff. So the first thing we did is we found common denominators. So I'm going to do a little bit of erasing here and walk you through the thought process to connect this to multiplication. So we've got 3/5 divided by 1/4. And the first thing I did then was find common denominators. So I had 3 times 4 divided by 5 times 4. And we were dividing that by 1 times 5 over 4 times 5. So the 3/5 becomes this, and the 1/4 becomes this. And we are going to leave these in factored form. Instead of multiplying it out like we did down here, let's leave them in this factored form and take a look and see what happens. Well, these right here will be the 20ths, so they're going to divide away. So I've got 3 times 4 divided by 1 times 5. So I've got 12 divided by 5, or 12/5. So another way to look at it is I wind up with 3/5 divided by, nope, that's the wrong way to write that. I'm trying to be very careful here and put this down in a way that makes sense. So I've got my 3 times 4 divided by my 1 times 5, which then becomes my 12/5. So writing it slightly differently than I had just written it. Now, interestingly, 12/5 is what we wound up with right here. So this 3 times 4 is the same as our invert and multiply. 3/5 times 4 over 1. Here's my 3 times 4. Here's my 5 times 1. So by thinking through what I did with the division, I can see where I end up with the multiplication. I'm going to try that one again real quickly, just kind of trying to explain it one more time so that we can see the connection here. So I've got my 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ooh. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. And I've got my 12/20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12/20ths. And I'm counting groups of 5/20ths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got 2 and 2/5. And I can see that on my model. And so what I did number sentence wise is I took my 3/5 and I multiplied both of the parts times 4, which gave me the 12/20ths. And I took my 1/4 and I multiplied both of the parts times 5, which gave me my 5/20ths. So here's my 12/20ths, here's my 5/20ths. If I put this all together, I've got 3 times 4 divided by 1 times 5. Underneath here, I've got 5 times 4 divided by 4 times 5. And these will cancel each other out. 20 divided by 20. And remember, this expression stuff that I'm showing you here with the 3 times 4 and 1 times 5, this all is what we did up above. Here's the 12/20ths, this right here. Here are the 5/20ths, right here. So all of this stuff that I'm doing ties directly to our model. So the 20ths will cancel out, and I am left with 12 divided by 5, which is exactly what I would get if I had 3/5 times 4 over 1, the multiplicative inverse. So I've got 2/3 divided by 3/4. 2/3 is 3/4 of a number. 2/3 is 3/4, so I need 1, 2, 3. So there's my 3/4. And I've got my 2/3 is equal to that. 2/3 is 3/4. Now I need to take that 2/3 and I need to cut it into 3 parts. So I've got my 2/3. There's my 2/3, and I need to make 3 pieces out of it, 3 parts. There we go, there's my 3 parts. So the 2/3 is going to be equal to 1, 2, 3, 4, 5, 6 ninths. So what we have done number sentence-wise is I've got 2/3 is 3/4 of. So I've taken my 2/3 and I have found 1/3 of it. And the 1/3 of it is going to be 3/9. Nope, not 3/9. 2/9. 1/3 of it. 2/9. 2/9 is going to be 2/9 then. Now I get to do a little bit of erasing. So I've got 2/9, and there are 4 of them as I scale up here. So I've got my 2/3, and I find 1/3 of it, and I multiply it times 4. So I've got 2/3 times 1/3 times 4 over 1, which gives me 2 times 4 and 3 times 3. And I'm trying very hard to connect that straight up to our reciprocal, and I get 8/9. So right up here, if I am to use the multiplicative inverse, 2/3 times 4/3, 8/9. So a nice little connection there between our division expression and our multiplication expression. All right, so quick closing thoughts here. Dividing by a fraction is equivalent to multiplying by its reciprocal or multiplicative inverse. We call this the invert and multiply rule. Now it's important as we look at the invert and multiply. We are using the divisor. We are not doing anything with the dividend. The reciprocal that we use is the divisor. The divisor, the second number. So 3/4 divided by half is the same as 3/4 times 2 over 1. Notice it is the divisor that we are using the multiplicative inverse of. Does it matter which interpretation of division we use? Can we always invert and multiply? In other words, can we use partitive and measurement? And we've looked at examples of both of them today. So it doesn't matter. The invert and multiply rule is going to work for any of our division problems. And when we say any of our division problems, even 5 divided by 2, so these are whole numbers, invert and multiply, which is why in class I always say that multiplying, dividing, it's kind of the same thing. All right, so here we have our general form. Connecting models of fraction, division, and multiplication through the use of reciprocals helps in understanding the invert and multiply rule. And here is the invert and multiply rule. So notice that the dividends are unchanged. but we have taken the divisor and we have inverted and we have multiplied. All right, so looking at the I can statements here, I can show and explain the connection between models of fraction division to multiplication. And I know that that is a tall task, which is why we spent a whole lesson just doing examples. But we need to be able to look at our models and actually see step by step what it is that we're doing. I can show and explain the invert and multiply rule. So this concludes Module 2, Lesson 7. If you've got questions, make sure you talk to your teacher. Make sure you complete the problem set.